Hi, I'm David Tao and you're watching the Theories of Everything program. In an earlier program on theories of the mind, we discussed, first of all, some of the early philosophical approaches to discovering the nature of the internal mind and the nature of external reality, to bring the two together. Early philosophers really struggled over this particular problem, amongst them being Plato and Aristotle. As we discussed, Plato saw the cosmos in an idealistic framework, in an abstract idealistic mode, while Aristotle decided that all experience had to come from the senses, through the senses to the mind. And later philosophers in the 17th and 18th and 19th centuries also were bedevilled, if you like, by this paradox. Was knowledge generated innately, internally and subjectively from the mind, or did it originate outside through the senses, through the external reality? Foremost amongst the rationalists, those who believed that true knowledge was generated internally, was Descartes. And he's very famous and well known for his phrase, "I think, therefore I am." In other words, the thinking is the dominant aspect, and only because of that he exists. He established what was known as the Cartesian dualism, the mind and body, the split between the mind and the body. The body was a material thing, the mind was something different that no one really knew in what form it existed. And so, down through the ages, the rationalists and then the empiricists, who believed that all experience and all knowledge was generated through the senses, and then came into the mind as ideas and thoughts, and then generated words and language. This continuous debate resonated, if you like, right down through the centuries to today. And we discussed that in our first program. Now, in this program, we'll be continuing to delve into the mind, and we'll be continuing to look at some of the more esoteric aspects that until recently, until possibly the last decade, have been very difficult indeed to understand. And the reason it's become easier to understand some of these more esoteric aspects, such as dreams and hallucinations, meditation and so forth, is because of the new electronic probing techniques that are now available, in the form of magnetic resonance imaging, in the form of positron emission tomography, PET tomography, and the other one which we discussed last week, magnetoencephalograms, which is picking up small variations in the magnetic field around the brain. These techniques have been a huge boon to neuroscience, because they're broadly non-invasive techniques. You don't have to probe with electrodes to get the information, and you can basically gain it from the outside of the brain, and electrodes are used sometimes, but only on the surface of the scalp. But it's enabled even things like memories to be probed. It enables functions such as doing a calculation, concentrating on something, even playing chess, and even gambling recently. When any of these events are happening, it's possible to probe the mind and see where they're affecting, which particular area of the brain is being affected by the rush of blood and the increased blood flow to that area. One of the other things that we discussed last week, and which leads into our program today, was the method of storing information and memories. And we found that the methods of storage related to the release of neurotransmitters in the synapses between nerve cells, between neurons. And this release of neurotransmitters was mediated by an electric current that flows once the voltage coming into the cell reaches a certain threshold. And there may be, as we described, thousands of neurons connected and developing to a particular cell and developing that voltage. Once it reaches a threshold, there's a cascade of ions, usually calcium ions, released, which releases neurotransmitters and connects to the next cell. And for the first time, for example, it's better understood that there are chemicals, in fact, that can boost memory. The main group of memory boosters are known as ampakines. They're chemicals that raise or lower the threshold of the memory process. The memory process is generally mediated by a neurotransmitter called glutamate, and that has receptors, MNDA receptors, on the receiving neuron. The gene coding for those receptors is generated in the hippocampus, and if that gene is not present, experiments done with rats in mazes, for example, have shown that the rats are all over the place and just can't concentrate and can't remember. But once the rats have been fed ampakines, their ability to negotiate the maze is increased by about 50%. In other words, their ability to get round the maze and remember the different places in the maze is improved by 50% at least. So it's quite a powerful memory booster. How long it'll take for these ampakines, which have their own receptors, the AMPA receptors on the receiving neuron, how long it'll take for them to become mainstream in human culture, I'm not sure, but it should lead to greatly improved exam results at the least. Now, in the last show, we also examined the concept of a blueprint for memories. We said that it's now been realised that every significant memory that we lay down is stored somewhere archivally. Often, though, it's stored away in the subconscious so that it's not readily available. It's also realised that it's quite vital that sometimes memories are suppressed, particularly traumatic events, for example. The mind may not want to relive these over and over. So those memories are inhibited, if you like, rather than enhanced, as in the brain boosters. There's another reason why the brain may be required to suppress unwanted memories, and that's because too much junk could possibly build up. If everything is remembered and everything is on tap all the time, obviously the number of memories is vast, and it may in fact clog up the brain and the mental processes. Now, this is seen most in the most definite form in the savant syndrome. That's where people have impaired mental capabilities are often extremely good at recovering information about dates or information about being able to play a piece of music if they've heard it once, and the ability to draw something that they may have seen once perfectly. It's usually in that being able to recover numbers, for example, that this is most commonly seen in the savant syndrome. Now, that's fine, except that those same people are unable to synthesize information adequately, have real problems at the higher level of cognitive analysis, and so are excellent, if you like, at have a photographic memory, but lack the ability to look at the big picture. And in fact, lack the ability to be creative, to be able to see the patterns in amongst all the information. Now, in most people, the brain does this automatically. But again, in a certain proportion of the population, and even in others who aren't mentally impaired but have excellent photographic memories and can pass exams without any trouble by regurgitating, if you like, the information that was required, there is a problem for those people in being able to create and see across the patterns of what they have remembered. So it is an aspect of creativity, this ability to submerge and to cover up, if you like, a lot of the day-to-day detail. So there's a lot of work going on this particular area of the mind at Sydney University, for example, and we may be looking at that aspect in a little more depth in a subsequent program. We've examined a number of mechanisms for laying down memories in the brain via the mechanism of synapses, neurotransmitters, etc. But one component that's also essential in laying down memories is now found to be sleep. Investigations of sleep have been going on for a long, long time, and it was mainly thought that sleep was advantageous in terms of regenerating the physical processes of the body. But it's now also seen that it's essential for confirming those memories that we wish to keep, and it's done during the several phases of the sleep cycle, particularly in the so-called rapid eye movement phase. Sleep can be broken into two phases: the standard long, slow, large wave type sleep, or deep sleep, and then the rapid eye movement sleep, which is smaller, shorter, faster wave patterns, in which there's a whole process going on which is connected to dreaming. So the connection is that long-term memories during sleep, memories that come in during the preceding day are sifted, they're categorised, they're related to previous knowledge, etc. And the memory traces are confirmed. They're actually reinforced so that those memories are retained. Now, it's no fluke then that sometimes we go to bed with a particular problem that can't be resolved or is difficult to resolve, and in the morning there's a solution, because during the night the mind has been actively working at the subconscious level on resolving ambiguities in information that have come in, resolving ambiguities in the sorts of information, and relating it to other types of information which may produce a solution in the case of a particular problem. So this has only really been pinned down in the last decade, the fact that sleep is essential for laying down or doing the final part of the laying down of memories. And that's associated with dreaming as well, because dreaming is now seen to be associated with the rapid eye movement component of sleep. 4 or 5 times during the night we seem to come closer to the surface of consciousness and dreams manifest, though we don't always remember them. Now, this is the investigation into dreams has been going on for a long time, and of course Freud was put up one of the main theories for dreaming, and he postulated that dreams were related to infantile wishes and emotions that arose in the subconscious, which were controlled during the day by the ego, so-called, or part of the conscious brain, repressed, but then surfaced in the form of dreams in cryptic symbols during the dream sequences, and they could be deconstructed and understood if you could understand the symbolic nature of the patterns that emerged. However, a much more sort of pragmatic approach to theory of dreaming has come to the fore more recently. Now, the limbic system of the brain is where the basic emotions are generated, where the basic reflexes are generated, and information from the limbic system is transmitted to the cortex, the higher level planning and analytical area of the brain, for processing and for further analysis. Now, during the evening, during REM sleep, during night, this limbic system is firing away randomly, and that even though there's nothing in the visual field, electrical activity is going on, and those pulses are being fired through the neurons to the cortex. The cortex tries to figure out what is going on, and it says, what is this I've received? And it tries to match up the random firing patterns of this subcortical area, limbic area, with what it already has in memory. And so it drags out of memory a number of previously stored pieces of information and then connects those up, because the pattern goes on randomly firing. It goes on and on, connecting these pieces together. Now, it's pieces of information or visual memory, if you like. However, associated with that connection into scenarios, if you like, are the associations which we've previously made. So if a random pattern is fired that suggests a connection with meeting an exam deadline, for example, the cortex will retrieve from memory a visual pattern of running down a hallway, opening doors, trying to find the exam room, for example, that might have been there previously stored. And it will connect the two. So you have this random pattern which generates this anxiety about finding the right room, which is associated with some form of anxiety that may have been previously related to meeting an exam deadline. So but the initiation of the dream comes from this random firing pattern, again, which is interpreted by the cortex, and then all these different patterns are linked together. To prove this theory, a number of experiments involving other species such as rats and cats have been performed. It's known, for example, that the initial firings from the brainstem to the cortex are mediated by a number of other specialised neurons. In the case of cat experiments, when these neurons have been cut, the cat has no inhibition on its movements, so it gets up as it's dreaming and arches its back and so forth. So in other words, we go through these scenarios, often extremely weird, but still related to our the context of our belief systems. So there is the ability to make symbolic sense out of them, but they're triggered by this random firing. However, we remain still. We don't actually physically go through the process unless those particular connecting neurons are severed. So that's where the actual proof comes from and where the experiments are at the moment. So we find that dreaming and sleep and memory are all interconnected. It's very important, not only for humans but all species, again, because during this sifting process and categorising the information that's come in through the day, emerges, if you like, a better method of handling the day-to-day problems of the world. In the case of lower-level species, lower-level mammals, it's a way of survival. They've got to reprocess the events that occurred in their lives, in their particular day life, so that they can improve on that and basically survive a bit better the next day. So it's all connected with survival, and in the case of humans, the way we handle our day-to-day information that pours in on us is equally important, because it allows us to improve our lifestyle, if you like, to constantly take note of what's happened and mesh it in with our previous experience. We previously mentioned drugs that boost memory, and they do this by lowering the threshold on the neurotransmitter to a certain extent. And they do it also by exciting the electrical activity of the neuron. However, other drugs such as LSD have a much greater impact and fairly unpredictable effect on the mind. In fact, as we know, LSD produces strange patterns in the mind. And these have now been categorised. They've been categorised broadly as producing patterns of tunnels and spirals and mosaics, cobwebs, honeycombs, for example. But what do these patterns mean? Is there a biological meaning rather than a sort of symbolic meaning to these patterns? It certainly seems to those ingesting the drugs that they're on the verge of a new dimension, of almost a new world. And shamans have been known also to take hallucinatory drugs to produce these sorts of effects. So the analysis seems, the latest theories seem to go along roughly along these lines. The hallucinatory drugs, such as LSD, lower the thresholds of neurons, for example, in the visual cortex, to the point where the neurons fire even though nothing is being visualised, there's nothing in the field of vision. The threshold is lowered to such an extent that it doesn't matter that there's nothing there, the brain just fires away, because there are two competing processes with neurons. There's the inputs that excite the neuron to up to its a threshold where it releases ions, and there's neurons that inhibit the firing of that neuron. So there's two competing forces, much as there is in a convection current, with streams of fluid going up, hot fluid going up and cold fluids coming down. So you have diffusion currents and you have diffusion currents of neurons firing. And that's fine, and these are sort of in the form of parallel lines, if you like, of firing when the neurons fire at a certain point. However, when the cortex and the visual cortex examines a scene, it places greater emphasis on or gives added weighting to the neurons at the centre of the scene, and lesser emphasis to those neurons picking up information toward the edges of the scene. So what it does effectively is compress the information, the parallel lines coming from the neurons firing are sucked in at the middle. And when you suck in those sort of firing patterns, you produce tunnels and you produce spirals. And this seems to be so what you're actually seeing under the influence of LSD is the inner architecture of the brain. You're seeing the firing patterns in response to not necessarily much at all, but you're delving right into the brain, which in some ways is what LSD, people under the influence of LSD believe is happening. They're seeing deep into their brain, into the actual firing of the neural structures. So in fact, hallucinatory drugs can help us determine the essence of the mind, where the mind comes from, and can in fact help us delve into what is meant by consciousness, which is something that we'll be examining in the third part of this series. So it has value to understand the research into hallucinations is vital to understanding the inner processes of the mind. Delving into one's inner consciousness through the use of hallucinatory drugs has its counterpart in the process of meditation, which can take one of two forms. It can produce a feeling of oneness with the universe, or it can produce a feeling of awe or numinousness. That's the objective of the meditation process, the ability to delve into the inner mind. Now, to delve further into this process, a number of experiments have been performed, and one recent one involved 8 experienced meditators. And of course they were probed using the techniques that we discussed earlier in the program, the techniques that measure the blood flow to a particular areas of the brain that are affected by the process that's occurring, in this case meditation. In this case, after a certain amount of time, at the point when the meditators started to feel this incredible rush, this incredible feeling of oneness outside their bodily state, at that point the images of the brain images showed some very interesting phenomena. They mainly showed that there's a point in the cortex called the parietal lobe at the back of the cortex that codes for the boundary, if you like, or the distinction between the self and the other, or the rest of the universe, if you like. Now, there's two parts to that. One part of that codes for the individual self, and the other codes for the context. And at the point where they felt themselves, that boundary dissolving between self and other, where they felt this extreme euphoria, if you like, at that point there was less activity in this area rather than more. In other words, the self had dissolved at this point, according to the brain maps that were produced. They had separated from all the other processes, the sensory inputs that normally come into that area. So there was a blurring between this distinct area, the boundaries, if you like, the boundaries dissolved. So meditation can induce a feeling of oneness with the universe, but for feelings of intense joy and perhaps even a religious experience, the system that's required to be invoked is the limbic system, the emotional system. And between the two, it can induce feelings of intense religious experience, and again a feeling of that religious experience extends across the universe. This can be also induced artificially by a device called a transcranial magnetic stimulation, or TMS device, that is a small magnetic field rotating anti-clockwise around the temporal lobes, and it can induce this feeling of a presence, or feeling even of a religious, godlike phenomenon also. So it's now understood that the brain can produce, or the mind can produce, these feelings quite independently of an external, outside stimulus. So we come back to the original philosophical debate between the rationalists and empiricists. How do we relate these internal feelings of awe and oneness and our own understanding of self with the ways that we measure them in reality, through electrical circuits, through magnetic fields, etc.? How do we bring those two elements together? And the only way that we can do it is through a better understanding of the process of consciousness. And that's what we'll be looking at in part 3 of this program of Theories of the Mind. I'm David Tao, and you've been watching the Theories of Everything program. I'll look forward to seeing you again next week.